Hello and welcome to another video. Today we're going to be working on is subsequence. And in this problem you're given two strings s and t, and you want to return true if s is a subsequence of t. And a subsequence is a string that's formed by the original string by deleting some characters without distributing the relative positions. So in this example, ABC is that in AHBGDC. And basically what they mean is, can you get rid of some characters here to make your string say ABC? And yes, you can, obviously, right? So this would be ABC. Then in the second example is AXC and AHBGDC, and that one is not, because there is no X. So the way to do this is actually really straightforward, because if the order must be preserved, it's really easy. All you do, let's just go through it, is you have a pointer to each of these. So you actually only need a pointer to the first one. And then you loop through every single character in the other one. And if the characters match, you simply move up your pointer. So let's see what that's going to look like. So we have a pointer at the start. Check. Do these characters match? Yes, they do. So we move this up. Now we check this character. Do they match? No. Do they match here? Yes. We move this up. Match, no, no, yes, move this up. And then once your pointer is out of bounds, that means you've successfully put in your entire substring into your original string. So that's pretty much all you need to do. Is you can just be greedy, and every time a character matches, you just move up your string. And when the characters match, you just simply move it up, or you just simply return true. And let's show what that's going to look like for the second example. So let's say we have AXC and AHBGDC. And we're going to do the same thing. So we are going to start here. We're going to say, do these characters match? Yes, they do. So let's move this up. And now nothing will match this X. So you will, once you're done with this substring, or once you're done with this string, if this pointer isn't at the end, then you return false. So you just simply check, is this pointer, whatever this is, let's call this like P, does it equal the length of S? And if it does, that means you went through your whole word. So you just check for this every time. And if this never happens and you went through your whole word and it still didn't happen, you just return true. So pretty straightforward problem, and now we can code it. So essentially we make a pointer, so we can just call that maybe like left. And we'll make it, we don't actually need to call it left. Let's just call it like P maybe, and we'll make it 0. And now we have to iterate through every single character in the big string, which is T. So we can say for char in T. And now we have to check for a match, right? So we have to check for a match, but the thing is, P can be 0 characters, so we'll check for that first, right? So we can just say if, or S can be 0 characters, because we don't want to be out of bounds. So we can say if P equals length S, let's just return true, because that means we went through the whole thing. We have to do this before checking for characters, because S can be an empty string. Or you could check for that before the function if you want to. That would also work. So now we will check for the match. So we can say if SP equals T, or not T, char, then we want to move up P. And so we're going to do this, and we are going to go through this for loop. But keep in mind, let's say the last character matched. Like, let's say our word was literally ABC and ABC. So in this case, you will never return true, because at the very end, like when this is true, you've already recursed out of the for loop. Or not recursed, but you're out of the for loop. So you need to check one more time after the for loop is over. So we can just return P equals length of S. So if it did actually, if this last character was the one we needed, this will return true. Otherwise, it will return false. So let's try to run that. That's actually... does work. And you can see it's reasonably efficient, or like as efficient as it gets for this problem. So yeah, let's go through the time and space now for this one. Pretty straightforward, right? It's an easy problem. So essentially we are looping through every character in T, and that's going to be it. We don't need to, like, we're checking for characters in S while we're checking in T. So it's not going to be like T plus S or anything. Because essentially, if S is greater than T, let's say, which I don't know if it can, I guess it can. If S is greater than T, then what would happen is we would just have looped through T and have checked some characters of S, but we're not always looping through the entire T of S. So in this case, our time is worst case going to be t, and best case, obviously we found it earlier, but worst case we're only going to loop through t. We're not. If s is longer than t, we're not going to loop through all of s. And for the space, we don't use any other variables, right? We just use this pointer, so that's out1. So yeah, easy problem, pretty fast. Hopefully you liked it, and if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.